I know we're hitting close to time, so I'll keep this very brief. One of the biggest things I think that if you're interested in actually understanding how much energy uh, controls can save is to ask manufacturers for their dimming curves. So they're going to either have the control voltage 0 to 10 on their x-axis, they're going to have the duty cycle, the pole width modulation on the x-axis, and then they're going to have the percent power on the y-axis. And again, it should go from 0 to 10, and there's a new ANSI NEMA standard, C137.1, which says exactly what those endpoints should be. But in practice, we're seeing a lot of manufacturers, not on the Hort side, but on the CNI side, not actually comply with C137.1, but at the very least, you could ask them to test it. They should get that information easily from their driver manufacturers so that you can understand if I fully dim this product, it only dims down to 30%, or it actually dims down to 10%. If I drive it at 100%, you might assume that it's full on, but some of the research has shown that it actually might have some sort of attenuation where it's not actually reaching its maximum light output at 100%, or conversely, it might be overdriven at 10 volts or 9 volts, way over 100%, and you're using a lot more power than you thought, thinking those diminishing returns, that could be problematic, right, for some growers, or it could give them another boost. But understanding how the system works, I think at the bare minimum is something that we should communicate better, and something where I'm very interested at for the future at the DLC. And then again, for spectral tuning, just assume it's set at the maximum. If growers are going to spectrally tune their plants, they're not going to do it just for yield. They're going to do it because they want other outcome measures. So certainly don't count on them doing it to save energy, because there's a lot more risk associated with doing that type of spectral tuning.